Good morning, everybody, or good afternoon to some of you, and welcome to the Reuse Company webinars. You will be muted during the webinar, but if you have any questions or comments, you can use the questions section and we will answer your questions at the end of the webinar. If you have any technical issues, please use the chat box. The webinar will be recorded, and in a few days we will send you the link to the recording. Today's topic is semantic traceability, how to keep the digital thread all along the systems engineering lifecycle. My name is Cecilia Karlsson, and I will be hosting today's webinar. With me, I have Jose Fuentes, Chief Operating Officer at the Reuse Company. This is the table of contents for the webinar. First, we will have a short presentation of the company and the presenter. Then Jose will go through the basic concept about traceability management. Next, we'll see what semantic traceability is. And after that, we will take a look at end-to-end traceability all along the systems engineering lifecycle. Then we will see a demonstration, and finally, we will have some time for questions and answers. So first, a few words about us. The Reuse Company was created in 1999 as a spin-off from the University in Madrid in Spain by system and software engineers. Our headquarters is in Madrid, but we also have an office in Stockholm in Sweden and a delegation in Tokyo in Japan. Very soon we are planning to open an office in the US. Our mission is to promote a reusable, scalable and global solution to a smart and interoperable systems engineering environment. And we do this by offering a semantic, knowledge-centric approach. The Reuse Company is a tool vendor specialized in the application of reuse methods, semantic technologies, and artificial intelligence to improve the digitalization of the systems engineering lifecycle. We are usually known in the market for our software tools RQA Quality Studio, RAT Authoring Tool, Traceability Studio, V&V Studio, and KM Knowledge Manager. And now we are launching our newest product, SES Engineering Studio. Our presenter today is Jose Fuentes. He is the Chief Sales Manager at the Reuse Company, and he is the former Product Manager of RQA Quality Studio and the Systems Engineering Suite. He has the Incosa CSAP certification and is graduated in the Incosa Institute for Technical Leadership. Jose is an active contributor to the Incosa Guide to Writing Requirements. He is certified in ITIL and is interested in project management, business analysis, and risk management. So let's start with today's topic. Good morning, Jose.
Good morning, Cecilia. Thank you for these kind words. So let's start this interesting topic of traceability. So let me change gears a little bit, because if you know me, I normally present a lot of webinars on the topic of requirements quality. So now today is traceability, something a little bit different. And let me start with a basic concept about what is traceability. So in fact, we think of, or we should perhaps think of traceability everywhere. Even with your breakfast, where is this milk coming from, or where is this coffee coming from? So this is, in fact, questions related to traceability, because we can define traceability like the capacity to find where a product was made, what the raw material and added components were used, how it was produced, and where it was produced, and how it has been manipulated and released. And all this has to be described all along the supply chain or the logistic chain, from beginning to the end, right? So this is a basic definition. It doesn't have to be in a systems engineering field. It could be everywhere, right? However, for us in systems engineering, I do think that we should understand a kind of similar thing about this. This is not, by the way, this definition is not coming from systems engineering field. This is more software, like the IEEE 830. related to software requirements. But what I like about this definition is that from the very beginning of the definition of what a software requirement is, it is said that it has to be traceable. And this is the important aspect for me, this traceability, right? So having traceability beforehand is the only way to deal with the verification of your requirements. So the only way to verify your systems is by enabling the proper traceability between requirements and tests, at least, right? So if we consider this like a basic definition of traceability in our field, then we should be happy just with this two-dimensional traceability matrix, like having test cases in the different rows of this table, and having the requirements or the use cases in the different columns of this table, and then just drawing some crosses here and there representing how all those test cases are testing the different requirements or needs, right? So this should be, let's say, enough in some context. So let's give us a champion cap, right? This could be good as a first step, allows to check where every requirement is coming from, allows, of course, to check if we are done, to which extent we are complete in doing our tests, ensures that implementation meets the specification and help us control scope creep and this kind of nasty things that normally happens with the requirements. It could be enough in some context, like let's say very simple software applications, right? However, it is clearly not enough in complex projects. It doesn't support the decomposition. I will mention this topic, the decomposition of requirements, and it doesn't cover other aspects like architecture or design or some other aspects, simulations and so on. And of course, it doesn't satisfy standards like and good practices like the ARP 4754 or DO standards in the avionics field, or the ISO 262 in automotive. So it clearly we need something else, right? If we look in detail some of those standards, then we can see interesting topics like that the requirements has to be uniquely identified and traceable. This is another definition. In this case, is a definition of what a safety requirement is, as included in the ARP 4754. And we see together with the definition this notion of traceability, right? So traceability requires to prove that requirements sets are sufficiently correct and complete so that the final product will meet the customer's needs. So when it comes to speak about customer needs, perhaps we should replace these customer needs by system requirements, especially if we want to distinguish between verification and validation. According to the INCOSE guides, the main difference lies on the confirming with the needs or confirming with the requirements, right? So this is the main difference between verification and validation, according to this guide. However, traceability is key in this avionics standard, but in many others, especially those related to the or under the umbrella of the 61508, like those in the railway, medical equipment, machinery, nuclear energy, automotive industry, as the one I mentioned before. So for all those requirements, standards and good practices, traceability is key, right? And what makes traceability a little bit complicated somehow is the notion of recursivity in our systems. So normally, in my first slide with this traceability or two-dimensional traceability matrix, that of course for this amount of information, it could be enough with having an Excel spreadsheet representing manually all this information. However, normally our systems are complex enough as to be decomposed at different levels, right? And it is in this decomposition where we could find difficulties in using just a plain spreadsheet to do to manage all these aspects related to traceability, right? So recursion is what makes things complicated. So because at the end, when you decompose your system, it is like in this this is, by the way, a screenshot of our tool Traceability Studio, where I have my requirements. So this is the traceability map, let's say, where we have defined that I will have my requirements. In this case, they are represented in doors. This is okay. Those system requirements are decomposed into different documents for the requirements for each one of the systems that build up into the full system of interest at the very top, so that all the subsystems are coming here, also in doors or doors next generation. However, so this is the decomposition I was mentioning before. In this slide, of course, I cannot include many levels of the composition, because if not, if I was adding those levels, you could not read the content. But the idea is that this could be further decomposed into more detail until you can take the decision of building, reusing, or buying each one of the different components, right? So until that moment, you could some of those subsystems could be further decomposed. And of course, this is where we need the help of a professional tool to do traceability. In this example, aside from requirements, as I was mentioning before, we can also trace to models. In this case, it is models in Capella, risks in Excel, stakeholder requirements also in Excel, very high-level goals coming from the statement of work in Word. So this is the traceability map, and of course the actual traces are not those arrows. These are the arrows for the map. The actual traces comes if I use this magnifier to see the detail of one of these arrows. Then I see that on the left it is not just a box name stakeholder requirements. It is that those stakeholder requirements are listed one after the other, in this case in Excel. The system requirements are in another repository, in doors in this case, and of course the actual traces are between the individual elements in here, right? So this is what we understand about requirements at different levels, right? And we like to take a step forward in this idea of traceability, coining the notion of semantic traceability. For those of you who know what we do at different aspects, like requirements quality and some others, we like this notion of semantic based on ontologies. For us, an ontology is made up of these 5 different layers, starting with the control vocabulary. At the end of the day, especially when we deal with textual artifacts like requirements, risks, the definition of defects in FMECA or FMEA approach. So all this is text. But if we deal with models, at the end of the day, the name of the model elements, or even the name of your functions or classes, even in your source code, are part of the vocabulary, right? So that's why for us, everything starts with control vocabulary, consistency in the way you name elements all along this traceability thread. This is our key aspect, the first layer of the ontology. Second is putting all this together, grouping those concepts according to their meaning or the nature of the concept, the actors, all the name of the actors all together into a class called actor, or the name of the systems in another class called system, or whatever, right? And also links and relationships between those elements, right? Layer number 3 is, especially as I said, for textual artifacts like requirements or risks, is the grammar, the structure for a well-formed requirement or a well-formed risk. This is layer number 3 of pattern. All this has to do a lot with humans, while the left-hand side of this has to do more with, let's say, with computers and the way computers first understand what is said. In this formalization layer, what our system is doing, let's say, in behind. This is something that the user is not seeing, but every time we deal with a requirement, for instance, or a risk, the tool will be doing this transformation formal representation from the actual input textual artifact into a semantic graph. So this is layer 4. And then layer 5 is what we call reasoning. Reasoning might come in our approach in different forms. If we speak about the requirements quality, reasoning is determining whether or not my requirement is meeting the rules. If we speak about traceability, it could be, as I will introduce in a moment, the notion of allowing the system suggest missing traces, right? So this is just an example of an actual representation of the 5 layers that I was describing before. We don't have time during this webinar to cope with this in detail. So I skip this a little bit, but perhaps if you follow us regularly, you have seen this slide plenty of different times. And this is, by the way, the notion of a pattern and the pattern transformation that I was introducing before, so that as soon as the tool detects, in this case, it is a requirement like this actual one in here, when ice is detected, the car shall show the ice icon in less than half a second from its detection. This requirement is actually fitting into, for instance, this pattern. This pattern is a typical pattern for a requirement, the one you can find in the 29148, for example, when with the first keyword, when, after, if, or while, condition, and then a particular subject that normally has to be a name of the system or subsystem or component, shall, and then an action, a verb, an action over another entity in my system, and then the constraint, right? So provided that the tool detects requirements following this pattern, automatically there will be a formal transformation into this semantic graph. Transforming into a semantic graph, it could be a semantic graph like this, or this is just another example representing properties in a kind of a property value approach, like the one you can see before. So this is what we call formal transformation of or semantic transformation of a requirement, right? So this makes us being a little bit more accurate and a little bit more in detail when we analyze elements, right? Like this is the same example as before, and we can go with magnify now to see or to watch what is the content of individual. In this case, it is a stakeholder requirement. The driver shall be able to control the temperature of the car. So this is a stakeholder requirement, right? If we move a little bit if we move to the statement of work, then perhaps we will find the definition of the actor driver, like the person who drives the car. So this is a basic definition, but it should be there. And and the same with there could be, of course, plenty of other requirements, use case diagrams, fault tree diagrams. And the good point in here is that if we speak about the driver in this as the subject for this stakeholder requirement, perhaps I would like my tool to automatically identify that this driver is the same driver as was defined in the glossary, was defined in my statement of work, right? So that changes in the definition of the driver in the statement of work could alert of suspicious links when it comes that these stakeholder requirements could be linked to other elements, and all this can be done automatically. In a similar way, we can think that if we are speaking here about the car, this car, which is the object of this stakeholder requirement, is the same car as is the subject in these other system requirements. Equally, this driver could be the actor in this use case diagram, or the control of the temperature could be just the name of this use case. And in this case, the control, so the thermostat that is mentioned here as the object, the car shall have a thermostat, is the subject of this other requirement, or the thermostat might have a fault tree analysis in here. So the idea is that by analyzing even the actual content of my textual requirements, we could have a tool that allows for suggestion of traces between different requirements documents, or between, for instance, requirements and models, and requirements and simulations, and so on and so forth, right? Perhaps I don't have time to show in detail all these simulation. I will focus this presentation in another topic. But if you want to learn more about the automatic generation of traces, I invite you to watch this webinar that I was presenting something like a year ago, more or less. I presented a little bit more, a year and a half now. I presented this other webinar. So please, when you get the slides, this is a link so that you can quickly find the webinar, scroll down and watch the recording, or download the slides. But today, I would like to focus more on the notion of end-to-end traceability, right? So I started with a very simple example where with only 2 dimensions, everything was done, just tests on the one hand and requirements on the other hand, right? So normally in those complex requirements, it is enough with just using whatever regular ALM, or even a requirements management system. These ALM tools, application lifecycle management tools, allows you to deal with requirements, tests, and risks, aside from other optional elements like perhaps issue management or something else, and provides you important activities like version control, configuration management, and change management. So basically speaking, this is what an ALM is, right? In this kind of tools, quality management is, let's say, very well implemented. It is based on the notion of completeness of traces. Are all my requirements properly traced to tests, and are all the tests properly satisfied or successfully executed, right? So this could be the way these tools implement the notion of quality. Of course, some of those tools are also capable to connect to automatic testing platforms like JUnit or NUnit or Cucumber or some others, right? So this is the way those tools deal with the notion of quality, which closes, I think, very well the loop between requirements and tests, right? However, normally these tools are not well integrated with other additional tools. In case other tools are integrated, it is normally done in a one-to-one or point-to-point way. High-level requirements in unstructured documents like Word or PDF are normally not pretty well covered in this kind of tools. Similarly to connection to other model-based tools like simulation, logical modeling, physical modeling, 3D. All this is normally not very well covered in here. Some are having connection to source code, some others are not. What about information inside relational databases? So how can, with these tools, how can we deal with traceability when the trace has to go beyond the 3 key elements managed in these kind of tools like requirements, tests, and risk? So if we need to trace to simulation, trace to code, trace to a specific paragraph in a regulatory document, so how can we deal with that? And believe it or not, but life is complicated sometimes. So please, I don't see your faces or I don't see your hands, but let me know if you have found projects like this in your professional career, like having a lot of information in models or even physical models like SolidWorks in here, or lots of information in Excel, Word, PDF, and some additional tools that perhaps are not part of the ALM. Of course, the ALM will be there, but there is always information in ERP systems. There is information like bill of materials, bill of information. So plenty of different pieces of information that eventually has to be traced, and your tool is not capable of tracing that. So what we have came out with is, as Cecilia was mentioning before, with the new tool in our tool suite, which is the Engineering Studio. And this tool allows for traceability aspects This is the current list of connectors. Of course, I understand that you cannot read anything in this table, but you can download this. You will get the link when you get the copy of the slides. You will get the link. So, so this is the number of different connectors that we have implemented in this tool. Another important aspect that we have implemented is a very good support to changes. Because for people, at least in Spain, my age, when I was a kid, I liked pretty much this TV commercial from Zurich, the insurance company, because change happens. And of course, change happens. You all know it in your project. So this means that perhaps you start with these requirements in here, but as the project goes over, some of those requirements are not requested anymore, are removed. Some other requirements are changed. Some other requirements are new requirements coming along the project, right? So the scope is changing clearly in this project, and and of course we need a tool, because it is that's why it is so important to have a professional tool. And importing and exporting, by the way, is not an option because of all those changes. So we need the source of truth always connected live, right? And that's why we have came out with our approach of what we call in this new version the interoperability hub, right? So this, or let me start by naming it interconnection hub, right? In our next webinar, as you will see at the end of this webinar, we will invite you to our next webinar about interoperability. For the moment, it is enough to describe it as an interconnection hub, where, as you can see in the drawing, for the user of our Engineering Studio tool, this is our user, you are actually connected to our repository. This is our database with the ontology inside, and all the different tools we can connect to. This list is not representing all the tools that were presented in the previous table, but this is just an example. All the tools that are connected to the repository are having a kind of exchange of information or are connected bidirectionally connected to the interoperability hub. That means that as soon as you link one more tool into this hub, then traceability is allowed among all those elements. There is no need to program point-to-point connections to provide traceability, for instance, between IBM doors, requirements in doors, and code in Visual Studio or C or whatever, right? So as soon as you connect one more tool to the bus, to the hub, then this traceability is allowed, right? So our notions are no one-to-one or point-to-point connectors. Source tools from many different disciplines can be connected, like requirements management systems, model-based tools, PLM, ALMs, even Microsoft Office or PDF, or even direct connection to relational databases. A no wipe-out approach. That means that if you want to use our Engineering Studio, there is no need to remove all the tools from the ecosystem. On the contrary, what we do is we embrace all of those tools within our approach. Changes in the source are notified to the Engineering Studio users and arise the notion of suspect links. This is fully automatic. Remove elements in the sources are also notified, and arise also alerts in the traces. And changes in the Engineering Studio are persisted in the corresponding source of truth, because we do believe that this interoperability hub is the way to orchestrate the truth, but the truth is in the tools behind. So the truth in the requirements is still in your requirements management system. The truth in your models is still in your modeling tools. The truth in your simulation, or the truth in your code, right? So we do believe that the information has to remain there. However, synchronization, consistency, all this is what is guaranteed by connecting those tools to the interoperability hub. This is our idea. This is our notion. So just to sum up, we can say that traceability is a must in complex and safety critical projects, requested by many of the standards I was mentioning at the beginning, and provides visibility in complex projects. However, it is normally a tedious and manual task. In my previous webinar, I described how to automatize a little bit this suggestion of traces. It involves connection of tools that are not easy to connect. I will show you some in the next in my demo now. And it has to be aware of changes and the evolution of the projects, right? So this is everything we have been coping with in the new version of our tool that I will show you in a moment with a video, right? So this is the video is wow, it is almost 40 minutes, so I will move forward a little bit. So this is the Engineering Studio tool where I have already some connectors, mainly to requirements. I have some connections to doors, connection to risks, or connection to stakeholder requirements in Excel, right? Whenever I open one of my connections, the tool is now going to the source, in this case, doors, opening the door server and retrieving the requirements from doors. If there were any change or update done externally, then this should be notified in here, right? With these two columns will be notifying changes, as you will see in a minute, right? So how can I deal with traces, for instance, between these stakeholder requirements and my system requirements? Very easy. You open in the tool the traceability module, and the first point is to create, or let's say this is the traceability project. By the way, we normally like to work with at least 2 or more screens, physically speaking, 2 physical screens. For the matter of recording this or sharing a screen, I am just having everything in my single screen, but all those screens are dockable and you can dock in a second screen. So this is the map that I was showing you in the slides, where you can see that everything now, for the moment, it starts with the stakeholder requirements, then system requirements, and subsystems. So these are the, let's say, the 3 levels that so far are created as traces in this project. However, now I would like to add one more level, as you will see in a moment. So this is a traceability module between the stakeholder requirements and system requirements, and the traces are already created in this demo. The traces are already there, so you can see all the traces. You can export, import, and you can generate a traceability matrix. So everything is part of the tool, right? So let me move forward a little bit. In this case now, you can notice I have changed the tool. Now it is Word, Microsoft Word. And I have opened a statement of work. This statement of work is having 35 pages, but I am just interested in traces to the goals in this document, right? So this regular Word, I have included the add-on, SES Engineering Studio add-on. So I connect to the database. Almost everything you will see in this video is real time, right? Except for a point that is consuming a lot of time that I will tell you later. But all this is real time. So what I'm gonna do now is I connect this document to the ontology. The ontology detects that this is the first time you configure this document. So it will request you if you want to extract some information that is currently there, or if you want to add more information, how can you access to this security, or how can you configure? I will give myself access right to the document. Because remember, all this will be stored so the document will remain as a document in my server, but the engineering information will be stored in the database. So I have to give me access rights. And now, since I want to identify uniquely some elements, then I'm saying that all these elements will start with the prefix goal plus a number. You can change the styles if you wish. I will keep it as it is for the moment. So by this, we have identified what should be the content, or how the content should be identified. But now I want to tell the tool that I want to to extract some current information as traceable items. So there are 4 different mechanisms to extract information in here: textual, based on semantic clusters, inclusion patterns. But let me just use the most basic one, which is just checking text. So everything, every paragraph beginning that begins with the word goal will be considered as a requirement. As I said, sorry, as a traceable item. As I said, different mechanisms. I will show you some in the next part of this video. So when I click OK, and this is real time as well. Now the tool is parsing the document and has extracted my elements, goal 7, goal 2, so that those elements are fully synchronized. When I click on one of the elements, the tool is fully synchronizing the between the documental part and the engineering part of the screen, right? However, I noticed that there is a missing goal. I have to promise that when I recorded this video, it was not done on purpose, but there is a blank space in front of goal 1. So that's why the tool is starting with goal 2, 3, 4, 5, 6, 7, right? So I can save, of course. When I save, I am saving the document as a regular save of this Word document, but I am also saving this content for the first time to our repository, right? So now I'm going to take the first goal, and since it was not parsed because of this leading space, so I remove the space. And now there are two ways to deal with that. After removing, just clicking on finding word products again, so the same process, or you just select your paragraph. It could be one paragraph, it could be 20 with images, tables, whatever, and then you click on add. As soon as you click on add, you have one new element, which is, so you can notice the difference. The rest are already in the database. This is new. So when I save, now everything will be loaded in a second. Okay, here we are. So that means that information is in the repository. Now I can close Word, and I can go to the Engineering Studio again, right? If I go to Engineering Studio, I can open the connection screen, and I see that there's nothing about those goals. Whenever I refresh, then the statement of work is coming here. So I can double click on it, and now it is this is Engineering Studio. And now when I double click, it is not that the Word document itself, the full document, will appear in the screen, but what I will get is just the information I have decided in the parsing process that I am interested in. So that means my 7 goals, right? So I double click, one more screen. As I said, it is better to work with 2 physical screens, but for the moment I just dock, and I have the stakeholder requirements on the left, the goals on the right, and the traceability tool behind at the bottom, right? So what I'm going to do now is I'm going to create one more traceability module, in this case to link between the goals and the stakeholder requirements, right? So you give the name, the type of the traces to be created, optional description, and then of course you have to name which is the source, which are the goals in my Word document, in my statement of work, and the target of this trace, which are the stakeholder requirements in Excel. You click OK, and now what you get is a new module. If I go to the traceability map or module map, then you will see like there is one more box now. Remember that everything started a moment ago. Everything started with Excel, but now everything starts with statement of work, right? So I close this, and now we can very easily open the module that will be empty for the moment, of course, and no traces. But I can create traces very quickly, or I can even import those traces, just to make it quicker for the video, right? So 35 traces between my goals and my stakeholder requirements are now created. You can see these statistics. You can see like out of my 7 goals, there are only traces for 5 of them. So I'm not fully done in here. And for my 67 stakeholder requirements, 52% are traced, but not the rest. So that means that I am not yet done in the matter of this or establishing stakeholder requirements for my goals, right? I move forward a little bit, and now I want to show you another document, which is far more complicated in the structure, far more complicated than the structure of the previous one. So this is a real regulatory document coming from the European Union, right? And there are a large number of those regulatory documents. In this case, this is, for instance, the one that every domestic appliance shall comply with in Europe, right? So those complex documents are made up of different chapters, articles, and then every article has sections on it, section 1, 2, 3, 1A, 1B, 1C, and so on and so forth, right? So parsing this is a little bit more complicated. What I have just done is I have transformed, with the help of Word, I have transformed this PDF document into Word, and now I am connecting this document, as I did with the previous one. I connect this document to the repository. Similarly to the previous step, the tool will determine that this is the first time we connect this to the database, right? So the connection screen will appear. Here we are. In this connection screen, there are plenty of information in the tool, and the structure is pretty much complex. As I mentioned before, there are 4 different mechanisms to parse, to extract the current content of the document. However, as you will see in a moment, I want the IDs to be a little bit special. That's why none of these 4 mechanisms is fully working for me. So we have implemented yet another mechanism, which is the possibility for you to inject your own code to parse the document and to provide the proper ID to your documents. This is what I'm going to do now. Going to this external identification algorithm, that is something that even end users can do. The only bad news or good news is that it requires some sort of coding skills. In this case, it is C#, right? So I have a DLL here. I select my DLL, and it will. This is going to be also real time. It will parse the document. It is short. It is very short. It is only 17 pages long, and it will extract a number of different sections and subsections, articles, chapters, and everything, which is coming here. As you can notice, I wanted every of those subsections to be named with the letter B of point 4 of the second article of the first chapter. So this is C1A24B, right? So this complex ID is what has requested to have a kind of custom parsing algorithm. Similarly to the previous step, both sites are fully synchronized. I can click on the engineering grid to the right, and then the tool will scroll up or down to the specific element in the text. So now every important or relevant aspect of this regulatory document is properly identified, right? So by having it properly identified, then I can now do traces. So I'm gonna provide rights and everything. And now I save and move this into the Engineering Studio. So now in the Engineering Studio, you have now the connection in your project, the connection to this document. I can now open. As has happened before, the whole Word infrastructure is not coming up into the Engineering Studio, but the engineering grid with all the elements will appear here, right? So whenever I have this information, which is what you can find here below, chapter 1, article 1, article 2, and so on. So when you have this, now, of course, you can open, for instance, the system requirements, because I now want to trace between my system requirements and the different blocks of my regulatory document, right? So I'm connecting to doors. Here we are. So now we have both the regulatory document and the system requirements. I dock my different windows. To the left, I have the system requirements. To the right, I have the regulatory body. And now to the bottom, I will have the traceability screen. So next step is to create a traceability module between both requirements and regulatory body. You give a name. Now the type of trace. If this type regulates is not yet in the database, it is very easy to come out with a new type of trace. So you just right click, add, and you name your type of trace, like regulates, between, requirements as the source element. And articles in your regulation in the right. You click OK, and you select regulates. Okay, now just identify which elements are the source and the target. Of course, there are the two that are open, but remember that in the Engineering Studio, you can open more than 2, 3, 4 documents at the same time. So you pick now the regulatory document, you click OK, and now the connection between both documents is established. In the module map, you have now the document represented, and now you can go into the details of the trace. So tracing between your requirements and the information that was coming from this PDF document is as simple as just select or pick one of your sections in your regulatory document and one of your requirements in this case in the doors module, right? So click on your requirement, click on one specific section of one article in your regulatory body, and click on trace to establish the trace. So it is as simple as that, right? So you can import traces if you have those traces already created, or you can add those traces manually. So let me now move forward a little bit. In this additional block, I'm connecting three main elements. First is a model in Capella. So I push it forward. So this is the way we represent models in Capella. As I mentioned before, it is very important for a traceability tool not to deal just with textual artifacts like risks, tests, and requirements. So connecting to models is also equally important. And this is the representation that we are doing of this Capella model. I'm going to connect also to source code, in this case in Visual Studio. So this is the information that we extract. We can also extract even the code in our tool, similarly to the code you can see in your actual Visual Studio tool for coding. And my last connection will be a physical model from SolidWorks, right? So this is the information we represent from the model. In fact, the tree with the system and the subsystems and components and so on. This is, by the way, the only part that was not loaded in real time, because I have checked the option also to get the actual content from the model, meaning that we take the tree, but we also take the snapshots of the content of the models, right? And this actually takes a lot of time to, when I say a lot of time, I mean minutes, because this allows us to do these kind of things and manipulate a little bit the content on us, just as a read-only. This is important to mention. So this is on the front, and now you have the actual tool, so it works. And in behind, you have our representation in the Engineering Studio. Loading this model is pretty quick, but loading the model with the snapshots of all the elements is something that takes minutes in our approach, right? In our connection. But normally the idea is not is not, of course, never to replace the modeling tool. First, because you cannot edit or change anything in our Engineering Studio, first. And second, every time you do this kind of connections, there is always a license of the tool behind that is consumed. So there is a license of DOORS, a license of SolidWorks, a license of any one of the other tools that we are connecting to. So you cannot think of this Engineering Studio as a way to save licenses, let's say, right? But it is a way of saving a lot of time in doing traceability. So whenever I connect to all those sources, I can now go and modify a little bit the map of the traceability map by adding where is it? Where's the map? So if I add new modules, then I can do things like, for instance, tracing between source system requirement and logical functions in Capella. So tracing is as simple as that. You click increase temperature function for this requirement, which is speaking about increasing the temperature, right? I can go down, for instance, and take a physical component, and I can also trace with these other requirements in here, right? So all this is as simple as just clicking element on one side, clicking on the other side, and clicking on establishing the trace. As mentioned before, this tool also includes some mechanisms to do automatic tracing. In this case, it is very straightforward because we have textual requirements on the right. We have model elements with names in the model elements. And then it is very easy for us to establish traces, or to suggest, by the way, traces between this requirement, which is telling that the system is in a specific mode, combat mode, and the mode itself, the combat mode coming from the model, right? So in loading the Capella model, this is represented in our system like a state by name combat mode, which is the same name as is used in my model. So I accept this suggestion, and the rest still remains as suggested, right? So I can do similar things with, not with Capella this time, but I can create a connection to source code, to Visual Studio. And then similarly to what we have done before, increase temperature, the logical function is implemented in code in this C code, right? So you just pick your function and establish the trace, right? So tracing code is as simple as that. And now final is traces between the Capella model and the physical model in SolidWorks. So I create the traceability module. Move forward a little bit. And establishing the trace is as simple as before. You select an element from Capella. You can open the search screen if you wish to select your element in your physical model and establish the trace, right? So finally, once all your traces are created, you can go and I want to show you the impact analysis from the very high level to bottom. So starting from a goal. So I select my goal number 2, and then the impact analysis of the Engineering Studio allows you just to drill down a little bit just by double-clicking. Of course, you can see the details of the different elements that are connected. Please notice that this is not the same diagram as before. In the previous diagram, the module map, it is just representing the documents. Now I am representing the actual traces between the individual elements, right? So from a stakeholder requirement 1, there are 3 system requirements, system requirement 3, 4, and 25. And you can double click on requirement 3 or 4, and then you will see that the requirement 3 is flowed down into another requirement in the subsystem level. Similarly to requirement 4, it could be a different subsystem, and then from the subsystem requirements into the Capella functions or Capella content. These are 2 traces to 2 functions plus the trace to the mode that I was representing before. if we try to do the same with the physical model, it is going to be exactly the same, from the system requirement to Capella, and then from Capella to my part in the physical model. And that's all for this demonstration. I hope you enjoyed. And if you have any question, please, this is time for questions. Cecilia, could you please manage this block?
Yes, thank you very much, Jose, for your presentation. Jose will answer your questions in a minute. So if you have questions for him, please write them down in the questions section. Meanwhile, I will give you some information about our next webinar. It's called Connecting the Dots, Interoperability between your favorite systems engineering tools. With the connections established and traces completed, you will now be able to interoperate between them. You can generate different types of models from textual requirements to transform a model of specific type into a divergent one, do automatic rewriting of requirements to meet specific writing rules, etc. And the dates for this webinar are the 2nd and the 3rd of November. So over to the questions. How does the tool handle copying one product with traceability to a new product that is based on the original?
Well, if you mean two copies of the content of a project, just to create, as I think, if I understand what you mean, is creating models or requirements for another project or product which is pretty much similar. This is something that is not covered in this version. However, in next version, we expect a complete new component in the Engineering Studio that will be about the notion of reusing information from different projects, product line engineering, the variability models, and all these kind of things. So if your question is on those topics that I mentioned, variability models and the product line engineering and so on and so forth, the answer is that unfortunately, this is not covered today, but it will be very soon covered. So please drop me an email if you wish, and I will tell you when it is ready and how to access these capabilities. And please tell me if I understood you right first.
Thank you. Thank you, Jose. Which programming languages can you involve in your traces?
Well, in this demonstration, I have been using Visual Studio as the tool. So that means that every language that can be loaded in Visual Studio, like C, C#, Visual Basic.NET, and some others, can be loaded. However, very soon we will move forward into other kind of languages, right? Anyway. Please, I don't know who asked this question, but please send us your requests. So normally when we integrate our tools with other tools, it is by request or by demand of our current customers. If you're interested in parsing other programming languages, we can do the same. Just let us know and we will react to your demands.
Okay, thank you. Okay, so right now we don't have any further questions, but if you have questions later, you are very welcome to contact us by email, for example, to contact@reusecompany.com, directly to Jose, or through our website, reusecompany.com. Thank you very much for attending, and goodbye.